In the last topic of Chapter 2, Section 7, we're going to take a look at what are called linear inequalities. Here are the list of objectives, and when we talk about inequalities, some of the background, and this will just be for review, the symbols of inequalities, and this is a review from past lessons. This is the symbol for less than or equal to, greater than or equal to. Now, these are going to refer to whole sets of numbers, and generally we put our answers in what is called interval notation that is described here. So you're going to take a few moments, I'll pause, while we actually make a diagram or copy what we have here, and then we'll go over it with you. So you want to have examples on the left here, the terms involved, and then how it's shown in interval notation, and then what would the graph of it look like. All right, we'll pause. Okay, now as you do the examples in your practice and certify, you'll note that one of the things you have to do once you solve the inequality and end up with something that looks like this is pick out what will the interval notation look like. Will it be two sets of parentheses, a bracket, two sets of brackets, a bracket and a parenthesis and a bracket, or just a parenthesis and another parenthesis and a parenthesis? So these are all the scenarios that are going to be discussed. And the key, I'll make a little quick number line here, is if you're talking about a value of x, and x is included in the set, then in the old days we used to just put like a dot there. If x is greater than or equal to, that is the equal to, we're going to use a bracket. If x is only, and I'll take away the equal to, if x is only greater than, then we use a parenthesis facing the direction we're going to draw our arrow. Well, okay, a little bit of background, and then we'll, of course, use this as we go on. And the phrasing where there are only parentheses is an open interval. When there's brackets on both ends, it's a closed interval. Otherwise, it's considered a bracket. Parenthesis is half open. And I don't think we got this picture here yet. These, again, would be half open because they have a bracket and a parenthesis. So take a moment, sketch this last one if needed. In this item now, it'll be an example 1, and draw a number line. It says graph the open interval 3, positive infinity. So on your number line, you're going to sketch, and we're just interested in the 3, so you can shorten this up somewhat, a parenthesis. Now, a parenthesis means that 3 is not included in the set. And you thicken the line, it goes off to positive infinity. And in our software, after you've chosen parentheses, that would go on the line. you would move this parenthesis to the 3, this parenthesis to the end, and what forms then is the ellipsis. I'm going to jump in here and do an example from the practice just to show you how the software works. So I'd like you to write this as well. So I've written the example, and we'll be doing many of these in the Learn. But to solve it, we're just going to transpose that positive 3 to this side, where it becomes a negative 3, and then another negative 3 gives me a negative 6. So we have x is greater or equal to negative 6. Now, they're asking us to write the answer in interval notation. So based on what we've been doing, the number we're interested in here is a negative 6. Now, what symbol do we put at negative 6? Well, because it's also equal to negative 6 and greater, we're going to use a bracket, and it looks like that. And then we indicate that this is going to go to positive infinity. So in interval notation, it will be a bracket, negative 6, comma, positive infinity. Now, where do we get all of that from? Well, what we could do is we go to our keypad, and we can't see it too well. Let's see, can I move it over? No, but it's off screen a little bit here. I have to go to box over, and there you see the various choices. A set of parentheses, parenthesis bracket, bracket parenthesis, two brackets. I'm going to choose here a bracket and a parenthesis. So I'm going to click on this one. And notice what now appears in the answer box. So I'm going to type in there negative 6, comma, and then also here is my infinity symbol, which I've clicked on, and it forms there. And now I go over to where it says submit answer, and it says I got that right. Okay, now in part 2, they're going to ask us to put this on the number line, that is to make the graph. So once again, I have to select, let's see if I can get it working here. Well, I'll try it again because what I had picked out here was two brackets. I wanted to pick a bracket and a parenthesis, so it's kind of hard to see, but let's just do it again though. So there's the negative 6, and then I click on this and move it to the end where I then get my ellipsis, the 3 dots. I click submit answer, and they say I have it right. All right, so this is something I'm going to add so that you're familiar with how the software works. Now back to our Learn lesson. But you'll get practice on that. Let's go on. So in example 2, you have this to copy down, and it's read 0 is less than x is less than or equal to 4. So again, on your number line, the numbers you're interested in are 0 and 4. So you can just sketch those in. Now, since 0 is less than x, it's not included, and you're going to use a parenthesis here. And 4 is included because of less than or equal to, you're going to use a bracket. And that's what you pick up. And on the line, you move these values to these positions. Now, writing this in interval notation actually comes right from the graph. You're going to put a parenthesis here, a 0, and then a 4. But at the 4, you're going to use a bracket. So this is where we're moving to. All right, for example 3, again, a short number line. Now here, it says, what does this graph represent? So if we were to put it in algebra, we're going to say x. Now, what symbol would you use here? Greater than, or equal to? Well, because of the bracket, it's going to be greater than or equal to, and then the number is listed as 1. And this would be in interval notation, a bracket at 1, comma, and then a infinity symbol with a parenthesis. Now, infinity, whether it's negative or positive infinity, always is associated with a parenthesis. So this would be a half open interval. Again, you're learning some new vocabulary and then seeing how it's illustrated. For example 4 in your notes, again, you're going to make a number line and a parenthesis at -3, a parenthesis at 1. Putting this in algebra, we would have x in the middle, and x is greater than -3. And over here, x is less than a 1. So in interval notation, again, a parenthesis, a -3, a 1, and then a parenthesis. And this would be what we call an open interval because of the parentheses. Of solving inequalities, we see here a series of inequalities, but they're not laid out where x is something. We have to solve for x. Now, solving for x in an inequality is pretty much the same, except for one thing, and I'll illustrate that here. If we say 2 is less than 4, that's a true statement. Now, if we multiply this side by 2 and this side by 2, we get 4 is less than 8, and that's a true statement. But if in an inequality we multiply one side and of course the other by the same, a -2, watch what happens. Here this becomes a -4, and this becomes a -8. Now, is -4 less than -8? And the answer is no, that's not true. -4 is greater. So the one exception when we solve inequalities is if we have to multiply by a negative or divide by a negative one side of the inequality. In order to keep the statement true, we must reverse the sign of the inequality. So -4 now is greater than -8. That's the only difference. All right, let's go on. So in example 5, and note the numbers, please. Here we have y equals a -3.2. All we have to do is transpose that, add these two together, and we get y now is greater or equal to 8.8. This is the work you want to show. And then you want to put it on a graph. And because of the inequality sign, we're using a bracket. And one of the hints, one of my colleagues sometimes mentioned, is when you see the inequality sign and the point is on this side, that sort of indicates which direction the inequality line will go. Kind of follows the point. As long as your variable is positive, that's what we always want, the variable to be positive. And then putting this into interval notation, again, bracket, comma, positive infinity. But in our software, remember, we're going to just move it to the end of the line that's illustrated, and then the ellipsis forms. Now for number 6, you're including this, of course, in your notes. Here's an inequality with fractions. Now, they're not featuring that here, but we're going to review what we did earlier. Put a bracket around everything here. You're going to multiply to get rid of the fractions by a 5. So this becomes 5t. Here the 5's cancel out, and this becomes 4. Less than or equal to, this 5 cancels out, and this is a 1. So now we go 5t, transpose the 4, becomes a negative 4, so this becomes a negative 3, and we just divide both sides by 5. As we do in equations, and we get t is less than or equal to a negative 3/5. Well, putting this on a graph, let's say this is our negative 3/5. What symbol are we going to use here? Well, this is going to be a bracket, but which way will it face? Well, its t is less than, so it's going to face this way. And then you just draw your line, and here it's done anyway. And then putting this in interval notation, coming from negative infinity. Remember, infinity, whether it's negative or positive, is always a parenthesis in interval notation, and then up to negative 3/5. And because of the inequality sign, the negative 3/5 is also included, so you have a bracket. Now, even though I'm not writing them out, they're giving you some pretty good advice here. When I do it a little differently, you might try that, but again, this would be perfectly acceptable. Now, here they're going over this one difference between solving equations and solving inequalities, and that is dividing by a negative and multiplying by a negative. You have to reverse to the directions of the inequality sign to keep your inequality true. And of course, example 7 now. Again, it's as straightforward. Just as it would be an inequality, you're going to divide by the coefficient of x, which is a 5. Again, it's positive, so the signs don't change. And you get x is greater than 3. And again, on the number line, and in the software, you're going to pick a parenthesis and a parenthesis. Then the parenthesis forms. You move the parenthesis to a 3, and then move the other parenthesis to the end, where the ellipsis will form. And in interval notation, it is parenthesis 3, comma, infinity, parenthesis. Take a moment, get your notes. Now here, as we write out example 8, notice our x value is negative. So the numerical coefficient of this side is a negative 3. We are dividing by a negative 3. So this now becomes a positive x. But to keep this inequality statement true, I have to reverse the inequality sign. And this becomes a negative 4.1. Now, when we do the graph of this, and it looks like so, we're going to choose a bracket and a parenthesis. Goes to the line, we move the bracket to negative 4.1, and you can use your arrow keys as you're moving this. It makes it a little bit more accurate. And then parenthesis, and then this will be the ellipsis, and there is your interval notation. Again, we're covering lots of stuff in just one lesson, but you want to get some good notes and be sure to understand what's going on. And of course, always bring questions as needed. We're now going to deal with some multi-step linear equations, and the protocol is here, but we'll go over it as we see them. All right, let's pause and take a look at this. We'll solve these in a similar way that we did equations, and only have to reverse the inequality signs if we're going to divide or multiply by a negative. So here we're going to transpose the positive 5. So to this side becomes a negative 5. So this is a negative 6 here. And then 6x. Divide both sides by 6. And since we're not dividing or multiplying by a negative, it just becomes 6. The inequality sign stays the same, and this is negative 1. And again, this point indicates the line is going to go to the left. And again, you choose parenthesis and a bracket because our negative 1 is included in the set. And there's the interval notation. Now pause, get this down. This is example 9. We'll skip example 10 because they're done in a similar way. We'll go on to example 11. And skipping 11 as well, going on to 12. All right, this one's a little different, so let's work it from scratch. Now here, this is what we call a compound inequality, where there's a value on the left, something in the middle, and then a value on the right. We want to eventually solve for x. So for this, I would go back to that old method. To isolate this middle item, to get the x by itself, I'm going to add 1 here. But then I have to add 1 there and add 1 there. So this now gives me a negative 4 is less than or equal to 4x is less than 12. And then now to isolate the x, I'm going to divide this term by 4, this by 4, and this by 4. So I now get a negative 1 is less than or equal to x is less than 3. And that's what they end up with. Now when we put that on our graph, we're going to pick for this one a bracket, and for this one a parenthesis, put the negative 1 there, and the 3 there, and you now have an interval notation, the answer, as well as the graph of it. And if we go down, we can see the interval notation part down there below here. Okay. And for our last example, example 13, we'll move that up a little bit here so you can see the full work. Now, this is a little different because you'll notice that in the middle here, our x value is negative. So we're going to solve it in a similar way. We're going to get rid of this negative 3 by adding 3 there, adding 3 there, adding 3 there. So we get now 8 is less than or equal to a negative 2x is less than or equal to 16. Now here, it's interesting what we're going to be doing. Watch this carefully, because now we're going to get rid of our negative 2 to isolate a positive x. But when we do divide by negative 2, to keep this statement true, I have to reverse all my inequality signs. So this will become greater than or equal to. This will become greater than or equal to. And this is going to be a negative 8 here. This is going to be an x. And this is going to be a negative 4. But notice this looks a little bit backwards, because on the right now we have a smaller quantity, negative x. and over on this side a -4. So whenever you have this type of problem, I will always suggest that you rewrite this, putting the -8 on this side, and then keeping in mind the point now is toward the -8, so this is less than or equal to x. And again, the -4 over here, and the point now is toward the x, and now it reads correctly. The smaller value is on the left, the larger value is on the right, and there is the proper graph, and you've selected, in this case, 2 brackets, and then an interval notation right from the graph or from the algebraic expression. And that will wind this up. For our last example, and I know we're running over a little bit here, we're going to do example 14, applications now of linear inequalities. And here it deals with something we've done before, where we want to have an average that is greater than or equal to 90%. So we did one like this earlier. Copy this down. Again, they're going to add these up and then multiply both sides by 5. And then subtract this from the 450. And you get then that x is greater than or equal to 84 in order to maintain an average of 90% in order to receive an A in the class. Well, if it's only a 90, remember that's an A minus, but still an A. Okay, pause, get some material on this, and that will wind this up.